Let's talk about the distributive property. Now, I apologize, this video might be probably one of the longer ones that we're going to come across so far. So just bear with me. If at any point you need to stop, pause, or you can speed up the video, you can do that as well. Okay, so the distributive property basically kind of summed up looks like this. We have some kind of number multiplied by an operation happening inside a bracket. So that means that we distribute this into the bracket so that A multiplied by B plus C is equal to A times B plus A times C. So if I'm going to model that with algebra tile, I have 4 times x plus 3. So I'm going to write just those 4 multiplied by one singular x and then 3. So x plus 3. When I go ahead and do that, and I multiply, 1 times x is x, 1 times x is x, 1 times 1 is 1, 1 times the other one is 1. So we can see how once I've distributed it, how many x's do I have and how many 1's do I have? Well, I have 4 x's and I end up having 12 1's. So I write it as 4x plus 12. Or if I was to distribute this, 4 times x, and then 4 times positive 3, which would give me 12. So quickly expanding and simplify. So I'm going to distribute 3 into x plus 2. So 3 times x and 3 times positive 2 gives me 3x plus 6. I have negative 5 times 4m minus 3, negative 5 times 4m, and negative 5 times negative 3. I'll just write this out. Negative 5 times 4m, negative 5 times negative 3. I end up getting negative 20m plus 15. And then I have this on the example number 3. It's just written backwards, but I can distribute either way. Negative 4 times 5, negative 4 times 2y. And I end up getting negative 8y and negative 20. So what's the difference between 2y plus 5 times negative 4 and 2y plus 5 minus 4? Well, this one means multiplying everything by a factor of negative 4. Should put that negative in there. By negative 4. And this simply means we're subtracting 4 from 2y plus 5. So there is a big difference. Those brackets make a difference, and the distributive property makes a difference as well. So now we're going to quickly solve some of these. I need to distribute this x into x minus 3. So x times x times negative 3. I end up getting x times x is x squared, x times negative 3 is negative 3x. I need to distribute 2 into x plus 1, and I also need to distribute negative 3 into x minus 2. So 2 times x, 2 times 1 gives me 2x plus 2. Negative 3 times x, negative 3 times negative 2 is negative 6. So we can see how that negative needs to be distributed as well, and it affects the multiplication that's happening. Once I've expanded or distributed it, I'm going to go ahead and collect my like terms. I have 2x minus 3x, I'm left with negative x. 2 minus 6 gives me negative 4. This looks a little more complicated, but I'm going to follow the same distributive property. What that means is I'm going to take negative 3xy squared and multiply it by both terms inside the brackets. So negative 3x squared times 4x squared y squared, well, negative 3 times 4 is negative 12. X times x squared, well, I know to add those degrees, so I get x cubed. Y squared times y squared, adding those degrees, I get y to the power 4. I'm also distributing negative 3xy squared to negative 2x. Negative 3 times negative 2 is positive 6. X times x is x squared. And then y squared times, there's nothing else that affects it. It simply remains as y squared. And then we have 5xyz distributed into that bracket. I end up getting 15x cubed y squared z minus 5xyz cubed. Last one here, we're distributing it into 3 different areas or 3 different terms inside the brackets. So process stays the same. 6x cubed times 7x squared gives me 42x to the 5. 6x cubed times 5xy gives me 30x to the power of 4y. 6x cubed times negative 1 gives me negative 6x cubed. Okay, so that would be the distributive property into from one term into another. This is where things get a little bit more dicey when we're dealing with fractions. So I have 1 over 2 multiplied by 2x minus 6 minus 2 over 3 times 9x minus 6. So I'm just going to rewrite it a little bit, and I use the colors to kind of help show where things are going to go. When we say 1/2 multiplied by something, we are essentially saying what's half of the thing we're multiplying by. So I go ahead and I write it as 1 over 2 is the same as saying 1 multiplied by whatever the bracket is and everything divided by 2. This is the same as saying what is 2/3 of 3 and what is 2/3 of negative 6. Well, I'm going to rewrite it so that I have 2 times 9x minus 6 all divided by 3, because that means the same thing. Now I go ahead and I distribute the 1. So distributing the 1 basically changes nothing. So I'm left with 2x minus 6 divided by 2. And then I distribute the 2, so I would get 18x plus 12, right? 2 distributed in here, all that divided by 3. So now I can go ahead and I can actually take half of 2, which is 1, half of negative 6, which is negative 3. Or in this case, 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. 18 divided by 3 gives me 6. Remember, this is still a negative here. 18 divided by 3 gives me 6. 12 divided by 3 gives me 4. Now it's starting to look a little bit easier. I have my like terms, and I'm going to collect them and put them on either side. So collecting them, I have x minus 6x minus 3 minus 4. Right? Minus 3 and the minus 4. So I end up getting negative 5x plus 1. Okay? I have another example that I'm going to do the exact same thing. So for this one, I have negative 1 over 4 times 4x minus 8y minus 3 over 5 times 15x minus 10y. Right, so same idea. It's simply stating as what's 1/4 or negative 1/4 of 4. Well, I'm just going to write it out so it's a little bit easier so I don't deal with fractions. I simply leave the numerator and I multiply whatever is in the brackets here and then divide everything by 4, right? Same thing on this side. I take that negative 3 over 5 and I rewrite it so that my 3 multiplies the brackets, and then whatever comes of that, I divide by 5. I distribute my negative 1 into this bracket. I end up getting negative 4x plus 8y all over 4. And then I distribute this negative 3 into this bracket. So negative 3 times 15x, negative 45x, negative 3 times negative 10y gives me positive 30y. Again, that's all still divided by 5. Now I can go ahead and do the division that I can see. Negative 4 divided by 4 gives me negative 1. 8 divided by 4, or 8y divided by 4, gives me 2y. Negative 45x divided by 5, negative 9x. 30y divided by 5 gives me 6y. So now I go ahead and collect my like terms, and I'm left with negative 10x plus 8y. Okay? And this one here, I have what looks to be a lot more complicated because I have a lot of brackets, but let's break it down and go through our order of operations first. So I'm going to leave the 3 here, and then in my brackets, 2 plus 5, but the 5 is multiplied by 2x minus 1. So I have to do that first. That's multiplication. So 5 times 2x and 5 times negative 1, I end up getting 10x and negative 5. So the bracket now changes to 2 plus 10x minus 5. Well, now I go ahead and I collect my like terms inside the bracket first. So I'm left with 10x minus 3, all multiplied by 3, right? That hasn't gone anywhere. Now I just go back and use my distributive property. 3 times 10x, 3 times negative 3, I end up getting 30x and then negative 9, right? Now we have something with exponents. So 2 to the power 3 multiplied by 2 to the power 4 minus 2 multiplied by 2 to the power 5. Okay, there's a lot going on here. But what we can do is the actual math and evaluation. So I can take 2 and raise it to the power 4 and get an answer, which in this case is 16. So now I have 16 minus 2. I'm doing these brackets first because I can't really do anything out here first. Now that I have 16 minus 2, which I get 14, 2 to the power 3 multiplied by 2 to the power 5, I end up getting, well, 2 to the power 3 is 8, 14 stays, and then 2 to the power 5 is 32. Now I just have multiplication, 8 times 14 times 32, and I end up getting 3,584. Distributive property again, 6z into that term, so 6z times 2x squared y cubed z. I end up getting 12x squared y cubed z squared, right? Because z to the power of 1 and z to the power of 1, giving me z to the power of 2. 6z times negative 3x to the 5y, negative 18 x to the 5y z. And then 6z multiplied by 1z simply gives me 6z squared. Again, because this is a degree of 1 and that has a degree of 1. We have some tricky examples here. Again, I'm just going to kind of break it down before we go ahead and evaluate, because one thing we could do is we could just raise everything to the powers here and get really big numbers, but we don't want to do that because we know how to use exponent rules. I have 2 to the power of 3 times 2 to the power of 5, all divided by 2 to the power of 6. And that whole thing is multiplied by 2 squared minus 2 to the power of 5. So before I go any further, I'm going to clean this up. So 2 to the power of 3 times 2 to the power of 5 is the same as saying 2 to the power of 8. So then we have 2 to the power of 8 over 2 to the power of 6 multiplied by 2 squared minus 2 to the power of 5. I can divide, because these bases are similar, so 2 to the power of 8 divided by 2 to the power of 6 is the same as saying 2 squared, right? 8 minus 6. I've gone ahead and evaluated inside the brackets. 2 squared is 4. Negative 2 to the power of 5 is negative 32. I go ahead and perform the math inside the brackets because I have to do that first before doing anything outside of it. 4 minus 32 is negative 28 times 4 would be negative 112. The last one we're going to do here, I think it's the last one. Yep, last one. We have a lot going on. 1 over 2 AB multiplied by 6 times A plus 2 minus 8 times B minus 1 in the end bracket. Well, bedmass, I have to do inside the brackets first. So I'm going to distribute this 6 into this bracket, and I'm going to distribute this negative 8 into this bracket. So I'm left with 6A plus 12 minus 8B plus 8. Can I collect like terms inside my bracket? Yes, I can. I have 6A minus 8B, those say the same, but I have a positive 12 and a positive 8, which equal positive 20. So I can't collect anything more inside my bracket. Now I have to go back and distribute it again. So I distribute, this is the same as saying 1 over 2 times A times B. I'll just pencil that in over here. This is the same as saying 1 over 2 times A times B. So I can go ahead and distribute A and B into this before I distribute the 1/2, which is what I'm going to do. So I'm going to take AB and I'm going to multiply it by 6A. Well, AB times 6A gives me 6A squared B. AB times negative 8B gives me negative 8A B squared. AB times 20 gives me 20AB. So now I've distributed the variables, and now I need to multiply everything by 1/2. Or I can just simply think and ask myself, well, what's 6AB squared divided by 2? What's negative 8AB squared divided by 2? Because that's what we're really looking for, right? Half of 6, half of negative 8. I end up getting 3A squared B minus 4AB squared plus 10AB, right? Half of 6, half of negative 8, and half of 20, okay? So big takeaways from this, when we're talking about using that distributive property, making sure that, especially when we see ones like fractions like this, rewriting it so that it's easier to distribute and then go ahead and divide. If you feel more comfortable and want to actually multiply out the fraction into the brackets, you totally can. But for me, I'd rather write it like this so that's a lot easier to see what my next steps need to be.